Every remote clinical and administrative employee at Kestrel Health still gets onto the corporate network the same way: a VPN client, a login, and once that tunnel comes up, a standing badge that says you're inside now. From that point, the VPN doesn't ask again. It doesn't check which specific application a request is actually headed for, or whether the laptop making it still meets the posture Kestrel expects of it. It already answered the only question it was built to answer: are you on the network? And it treats that one answer as good for the rest of the session. A few episodes back in this arc, we fixed exactly this flaw for service talking to service. We never touched it for the humans logging in from home. Until now. It's worth being precise about what a corporate VPN actually does, architecturally, because the term gets used loosely. A VPN authenticates you once, at the tunnel's edge, and from that point forward, treats your device as though it were a desktop sitting inside the building, reachable by and able to reach whatever else lives on that same network segment. That's a network location decision, not an application-level one. It doesn't ask which specific system you're trying to reach, or whether you should be allowed to reach it right now. It asks once, at the start, whether you belong on the network at all, and treats yes as a standing answer for everything that follows. We named this exact failure back in episode 2, in passing, while cataloging why the old perimeter model collapsed. A VPN moves the perimeter's edge outward to include a remote device without removing the underlying assumption that once you're in, you're trusted. It doesn't fix implicit trust by network position. It just relocates where that implicit trust starts. And it's worth remembering what that specific flaw actually cost Kestrel. Back in episode 1, one phished contractor credential, and everything reachable from that network position was available to explore for 6 weeks. That contractor wasn't using a VPN in the original incident, but the shape of the flaw is identical. One point of authentication treated as a blanket grant to everything within reach, rather than a decision that has to be remade for every request. Picture this as 2 diagrams side by side, because the shape of the difference is the whole argument. On the left, the VPN model. A remote employee's device connects to a tunnel. The tunnel terminates inside the corporate network, and from that termination point, lines fan out to every system the segment can reach. Scheduling, billing, file shares, whatever else happens to sit on the same broad zone. One check at the tunnel unlocks all of it. On the right, the ZTNA model, Zero Trust Network Access. And the structural difference is that there's no tunnel into a network at all. A request for one specific application goes to a broker sitting in front of everything, not behind a perimeter, in front of it. That broker checks who's asking, what device they're asking from, and whether that device currently meets Kestrel's posture requirements, patched, encrypted, running approved software. Only if all of that clears does the broker open a narrow, application-specific path, not to the network, to that one resource, for that one request. The user is never placed on the network at any point in this picture, which is a different claim from placed on the network with tighter restrictions. There's no broad segment to reach at all, because ZTNA never grants network-level presence in the first place. Ask for a second application 5 minutes later, and the whole check happens again, from nothing. The same way the service mesh, a couple of episodes back, re-verifies every single call instead of trusting a session once it's open. If this sounds familiar, that's deliberate, not a coincidence of vocabulary. The episode on service mesh security showed a proxy sitting in front of every service call, verifying identity cryptographically before letting the call through, never once relying on which subnet a request came from. The episode right after that showed the same principle applied to blast radius directly, segmenting east-west traffic so that even a compromised service can only reach the small, deliberately narrow set of things its specific job requires. ZTNA is that same architectural principle, pointed at a different population, where the mesh verifies service-to-service calls and microsegmentation bounds what a compromised service can reach. ZTNA verifies human-to-application calls and bounds what a compromised employee credential can reach. Same question, asked of a different kind of requester. Not is this on the trusted network, but is this specific identity, on this specific device, allowed to make this specific request right now? Two checks sit underneath that question, and both have to clear before access opens. Identity verification confirms who's asking, typically through the same modern authentication this season has already covered. Ideally, phishing resistant, ideally tied to a real identity provider rather than a shared credential. Device posture confirms what they're asking from. Is the device managed? Is its disk encrypted? Is its operating system patched to whatever baseline Kestrel requires? Has it reported in recently enough for that baseline to still be trustworthy? Only when both clear does the broker open a connection, and critically, that connection is scoped to one application, not to a network segment. There's no lateral path for a compromised credential to explore because there's no network position granted for it to explore from. It gets exactly the one door it asked for and nothing standing next to it. ZTNA answers the access question for one category of traffic. A user reaching an application, it doesn't by itself say anything about the rest of what a distributed workforce needs from the network. General web traffic that needs filtering, traffic to sanctioned and unsanctioned cloud services that needs visibility, branch office links that need routing. That broader picture is what SASE, Secure Access Service Edge, actually names, and it's worth being precise about what the term is and isn't, because it gets used loosely too. SASE is a real architecture category, the term coined by Gartner, describing the convergence of networking and security functions that used to live as separate boxes and separate vendors into a single, cloud-delivered service. Concretely, SASE bundles 4 or 5 capabilities that traditionally shipped as distinct appliances sitting in a data center. SD-WAN handles the actual routing and connectivity layer, choosing the best path for traffic across multiple links rather than assuming everything backhauls to one location. ZTNA, what we just walked through, handles per application access instead of network-level VPN access. A secure web gateway filters and inspects general internet-bound traffic. A cloud access security broker gives visibility and control over which cloud services employees are actually using, sanctioned or not. And firewall-as-a-service delivers the inspection and policy enforcement a physical firewall used to provide, without the physical firewall. None of these 5 ideas is new on its own. What SASE actually contributes is delivering all of them from the same cloud-native edge, under one policy model, rather than as 5 separate appliances an architect has to individually procure, patch, and reconcile. Draw the 2 architectures side by side, and the reason this fits a distributed workforce becomes visual rather than abstract. Hub and spoke, the traditional model, every remote user and every branch office routes traffic back to a central data center first, because that's where the firewall, the web gateway, and the rest of the security stack physically live. A clinician working from home in one city routes through Kestrel's data center in another before reaching a cloud service that might be running minutes from where she started. Every one of those detours adds latency, and every one of them makes the central data center a choke point that has to scale with the entire organization's traffic all the time, even at 3 in the morning when almost nobody's on shift. SASE inverts this. Instead of one central enforcement point, everything backhauls through. Policy enforcement happens at a point of presence close to wherever the user actually is. A cloud edge location, typically one of many a SASE provider, operates across regions, chosen by proximity rather than by where Kestrel happens to own a building. The same identity check, the same device posture check, the same policy decision that used to require a round trip to a central data center now happens at the nearest edge node instead, whether the request is headed to an internal application or a public cloud service. For an estate that's genuinely distributed, remote staff spread across regions, workloads spread across more than one cloud provider, this isn't a minor efficiency gain. It's the difference between a security architecture that scales with where your people and your infrastructure actually are, and one that assumes both still cluster around a data center the way they did when hub and spoke was designed. Apply this back to Kestrel directly, because the worked example is exactly what makes it concrete rather than theoretical. Today, a remote clinical or administrative employee connects through the same corporate VPN this episode opened with. Authenticate once, get a tunnel, gain reach into a broad internal segment that includes far more than whatever single task that employee actually needs to perform right now. It's the identical architectural gap. Episode 1's contractor credential exploited, just sitting on the human side of the estate instead of the service side, and never addressed, while the last 2 episodes fixed its service-to-service equivalent. Replacing that VPN with ZTNA changes what connecting to work means at the architectural level, not just at the login screen. A remote nurse pulling up a patient scheduling application authenticates to that specific application on a device Kestrel has verified, meets posture requirements, and gets exactly that connection, nothing more. Needing the billing system 20 minutes later means a fresh request, verified again, scoped again to just that system. There's no standing tunnel into a shared network segment for a compromised laptop or a phished credential to ride sideways from, the same way there's no shared network segment for a compromised service to ride sideways from after last episode's microsegmentation work. Layer SASE underneath this, and the enforcement itself moves to a cloud edge point, near wherever that nurse actually is, rather than backhauling through a data center that was never sized for a workforce this distributed in the first place. The VPN doesn't just get replaced with something newer. It gets replaced with something that closes the exact gap it always had. 3 mistakes recur when organizations attempt this migration. First, treating ZTNA as a drop-in VPN replacement rather than a genuinely different model. Standing up a ZTNA broker, but configuring it to grant broad access to an entire application suite, instead of scoping each policy to the specific resource a role actually requires, which quietly recreates the VPN's flaw under a newer name. Second, adopting ZTNA for new access while leaving a legacy VPN running in parallel indefinitely as a fallback, which means the real attack surface is still whatever the weaker of the 2 paths allows, no matter how well the newer one is configured. A single lingering VPN concentrator, half forgotten and still accepting the same broad tunnel logins, undoes most of the benefit the migration was meant to deliver. Third, buying a SASE platform purely for its networking benefits, better routing, lower latency for a distributed workforce, without treating its ZTNA policies with the same rigor as any other zero-trust control. Letting device posture checks lapse, or letting default policies stay broader than they need to be, simply because the platform made broad access easy to configure. SASE and ZTNA are architecture decisions, not just infrastructure upgrades, and they only deliver the trust model this arc has been building if they are configured as though that were actually the point. That closes the loop on runtime enforcement for anything reaching into Kestrel's estate, mesh identity for service-to-service calls, microsegmentation bounding what any single compromised thing can reach, and now ZTNA and SASE doing the same for people wherever they happen to be working from. There's one major traffic path we haven't touched yet, and it's arguably the one attackers increasingly prefer over any of the others. The APIs sitting behind every one of these applications, reachable directly by anything that can craft the right request, human or not. Next episode covers API gateway security and the OWASP API top 10, where rate limiting, schema validation, and a failure class called broken object level authorization turn out to be just as load-bearing as everything this arc has covered so far. If you're building systems that need to survive a breach, not just try to avoid one. Subscribe, and I'll see you in the next one.